Hello, and welcome to the CFA Society San Francisco podcast, where we interview and discuss current topics with leading members of the Bay Area investment community. This week, Tanya Subatang, Senior Membership Manager with CFA Society San Francisco, sits down with Don Hejna, Managing Director at Stantum and Senior Principal Data Scientist at Accenture. Listen in as they discuss generative AI.
Hi, Don. Thanks for being on our show today. How are you?
I'm good, Tanya. Thanks for having me.
So today we're going to talk about one of the hottest topics in technological conversation, which is generative AI. And as Senior Principal Data Scientist for Accenture, you are the perfect person to talk to about this. So first and foremost, everyone's heard of AI, Gen AI, or whatever. But what is generative AI and how is it different from AI we've been talking about for years?
So the AI we've been talking about for many years was, stood for artificial intelligence. And that was the use of computers and algorithms to do things that traditionally humans did in the form of recognition. So for example, recognizing a dog or a cat in an image was generally what we thought about with artificial intelligence, measuring things like the sentiment of a movie review, and these types of things. What's different and distinguishing about generative AI is the evolution to generating things based on a text request or other information. And when I say generating things, it could be generating a summarization of a large body of text, could be generating an image, or it could be generating audio or even video. And so that's why the Gen AI label gets applied, because rather than recognizing or scoring things that you might see or read, it's actually generating new content, which for a long time was viewed as something uniquely human. And that's why I think it's gotten so much attention.
Now, what is large language model and how is that different from prior versions of AI?
So the large language model, which is really when people hear, ChatGPT and some of these other models, they're talking about a large language model, and the large adjective in the name comes from the fact that these are huge models in terms of the number of parameters and the amount of data they look at for training. And language model, because it's text-based, it's prose and any language, here in the US, it's mostly English. And the models themselves are trained on huge amounts of data that would boggle your mind, more than you could read in a lifetime, basically. And what became so interesting, and we'll talk about more, is the emergent behavior, which is after training these models to do a simple thing, initially it was just translation. Translate this from English to Spanish to German, et cetera. They found that the trained models could do things that were surprising, like answer questions and summarization. And we can talk more about that. But that's what lit the fuse on all the interest in the technology, is as these models got big enough and large enough to understand almost all aspects of language, they were able to sort of take instructions and execute tasks.
So then what do you think led the emergence and prominence of Gen AI and the explosive growth in the capabilities?
Yeah, the reason we're sort of blessed with this technology now is there's sort of three main areas. One, the compute resources are just much faster. Over the last decade, we've had huge increases in compute capability, particularly with GPUs that are very fast at certain types of mathematics. And I can go into the difference between a GPU and a CPU in a minute. The algorithms themselves have been optimized and evolved over time. And then the massive amount of data that's available on the internet in the form of print. And just to give you an idea of sort of how these three things fit together. So GPU, which stands for Graphics Processing Unit, was developed initially to render graphics and games and visual images and motion on computer screens. But the mathematics you do in that process is rather intense. And so they were focused on certain types of mostly matrix math operations that it turns out are also used in the process of training these large language models. And the way I want you to think about a GPU versus a CPU, if you go to a McDonald's drive-through and you look at the menu, you can do a number of different things. And that's like a CPU is very much like that. It's specialized in the fact that it can do all sorts of things, from calculate things on your Excel spreadsheet to load data and do a number of different things. GPUs are very specialized. So they're sort of like the toll booth at the Bay Bridge, if you know. They do one thing, which is sort of scan your license plate, or they take the change you toss in. There's one transaction. And the process, when you go, I'll use the Bay Bridge because people know this. when you go from sort of 4 lanes of traffic to about 10 lanes or 20 lanes of toll booths, you're fanning out that job in parallel, the job of taking everybody's money or reading their plate. And it all happens very fast. And then it comes back together. And the GPUs are basically doing that same thing. They're breaking the computations down into simple things that can be done repeatedly, and they're done very fast. And so if you think about the toll booth plaza fan out versus the McDonald's drive-through, that's very much a GPU versus CPU kind of analogy. And so that's why you see these companies like NVIDIA rising to such prominence in this area. So these GPUs are very specialized. They're essential for the computations that are involved. And it takes something, just to put it in perspective, it takes something like 300 compute years of calculations of these fastest GPUs to train some of these models. And if you think about that, which is mind-blowing, they solved that problem by doing it in parallel, massively in parallel. And that's where the algorithms and other things come in. And the last thing I want to just talk about a little bit is the data that is used to train these models. It was successful because the technique for training the model relied on just the data itself without a label. So what I mean by that is, instead of having humans read a sentence and summarize this sentence is about this, or this is a particular type of sentence, the researchers found a way to basically mask every word in a sentence and give it to the model and say, predict what the missing word is in this case, or look at the sentence that follows this sentence and tell me if you think it's likely that this is a natural continuation of the thought or a different thought altogether. And that training technique, which meant you could use unlabeled data, which is what I mean by that is the raw data in a book without a human ever having to summarize the book or things like this, allowed for this massive learning on training for these LLMs. And that meant we could use books, websites, newspapers, transcripts of interviews, look at the various styles of speaking, et cetera. And this LLM could incorporate all of that massive amount of training data while it's building its model.
Wow, that's quite impressive to kind of hear how that works. So how can we think about large language models and how they work?
Yeah, if you think about the way they're learning, they're examining lots of text and figuring out, using some complicated internals, they're figuring out what are the important parts of a sentence, what words affect meanings, how things go together. A classic example might be, Tom went to the bank to cash his check. And they're figuring out that his refers to Tom, and the bank, when it's talking about a check, means it's probably a financial institution and not a river bank, and things like this. And so it's basically looking at the context of all the words and how those words, I guess, interact and relate to one another, informing these concepts and compressing. This is the part that's not well understood, but basically compressing that information in such a way that the model itself gets very good at predicting missing words and next sentences. And in doing that, a side effect, if you will, of that training is it begins to sort of understand the important relationships between like pronouns and their objects, or if, like I mentioned, his check and Tom, et cetera. And that compressing of information that happens by looking at, literally billions of sentences and words is reduced to what I would call a sort of a network of knowledge stored internally that we don't really know how to tease out and look at individually, but you can see it working. And that gives rise to these things which are often known as emergent behavior. And so I'll give you an example. There was a large model that's called DALL-E, which was trained to generate images. And this was trained by feeding an image and its caption to the model and then asking it later to generate images. And many people have played with this. When the researchers finished training the model and they asked it to generate a sketch, they were surprised to find that the model actually understood that sketch meant basically a single color line drawing of an image. And they hadn't ever really said, by the way, this is what a sketch is. But the model had looked at so many pictures that were labeled sketch that it sort of figured this out. So that's an example of what people call emergent behavior. It's sort of this surprising thing that you didn't train directly, but the behavior emerges from all of this training. And I'll just say one thing. When you first train the models that we're referring to, these large language models, they're really just in a state of being a very good predictor, or like an autocomplete. If you've used Google and you watch it complete your sentence in the search bar, they're very good at doing that. But it turns out if you also train them to look at questions humans would answer and appropriate answers. It learns that there's if you reward the model, so to speak, during training for listening to a question and giving the right answer, you can train the model so that it behaves as sort of a question and answer like a chat agent or a chatbot would do, but do so with all of the knowledge it's seen during training.
Wow, that's definitely amazing to hear. So this is the question I'm sure a lot of people listening will have. And for anyone like yourself who's an expert in the topic, what types of transformations will large language models introduce in the workplace and industry, or even disruption?
Yeah, I think there'll be a number of changes. Most people tend to think of their job or fear their job being automated away, but I actually think the story is different. I think what we're going to see and all benefit from is people having sort of an assistant or augmented answers when they're performing a task. So what we see here is things like looking up facts, understanding questions, generating drafts of documents or responses to questions. Those are things that most humans do well, but they take time. And often if you've drafted an email, you know that you'll write it. And if you take the time to proofread it, you make some changes, you catch spelling errors and things like this. The interesting application for large language models is oftentimes you'll be able to give it a few pieces of information and say, please draft an email. And it will do a fantastic job of writing something that's generally middle of the road in terms of, balance and courteous and all those things. And then you can proofread that. So I think the job of the human using a large language model in a lot of their workflow will be to sort of proofread the output and steer it in a certain way. And a great example of that, one of the things that I think is most applicable is there's a demonstration from Salesforce using their technology where a user is chatting about an outdoor product, what jacket would be appropriate for the trip I'm taking to Montana in February. And while a human agent responding to that text would think, well, let me look up what the temperature is, et cetera. The LLM on the sort of side of the screen can basically look at that question, figure out what's relevant, like temperature and weather for the time of year and the location, and respond with a list of choices for the product that company offers and say, look, here's a suggested response. And the agent can then look at that and say, that's a good response, I'll just send it, or maybe make a few edits. So if you think about that task, that individual will be able to handle far more questions in less time and probably with a better quality because they're not going to be fatigued from looking all those things up. So what's the interesting result of this is that workers who, if you think about the spectrum of performance for a worker, and this could be due to ability, but it's more often due to just training or lack of experience on a job. Workers who have performed at, say, 50% proficiency, which means they're better than half their peers. When you add a large language model and augment, their sort of workflow with this, they will be performing at what would be usually 90 to 95% proficiency, better than 95% of their peers who were not using AI. And I think this, what I would call quality gain due to augmented assistance, is going to really change the workforce and the way, well, it'll raise our expectations a little bit and also help transform a lot of these repetitive industries. And what's interesting too is there was a study by MIT and Stanford researchers titled Generative AI at Work. This is from October of this year in 2023. And they noted that the productivity gains from generative AI were highest among workers with the least experience. So those who resolved they resolved 35% more chats per hour when they used a generative AI model. And the productivity for the people who were at the top of the skills level actually was basically flat. So it's more of an augmenter than a sort of an augmentative assistance than sort of replacing that. Now, there will be automation that replaces a lot of this, and I think you'll have that too. But we've become very accustomed to that when you order an airline ticket or, call into somewhere and they sort of ask what you're asking about and try to pre-screen the questions. Yeah. So the first transformation I think we talked about is the jobs that people do. And the second aspect is that, is people will generate things faster. So you'll be able to compose emails faster. You'll be proofreading, not generating so much. And I think writer's block will largely disappear. And to me, the evolution of the technology that will get better over time is that instead of giving generic answers, I think you'll get to the point where these models will learn and tune to your particular style, and even maybe say the style you're using towards different people. So I might write with a different tone to a coworker than I would to a boss. And I think as time goes on, you'll see that get sort of incorporated into the technology. In fact, there's an interesting result about automation from McKinsey that they looked at how automation will affect the workforce in the US. And I'll connect this to company and company performance in a minute. That basically by 2030, automation would take over about 22% of the hours worked in the US economy, which is mind-blowing in itself, just thinking about that. But with generative AI, that their estimate jumps to basically 30%, 29.5%. So generative AI is going to accelerate automation. And to put that in perspective, that means about a third of the time you spend today doing things like writing emails, reading a document that you're going to summarize and get the gist of, will all be handled through automation, and probably with these large language models driving the brunt of that change. So yeah, we talked about better results, faster results, less typos, more efficient use of human knowledge and high-skilled work. And as a result of that, I believe that businesses will become more efficient as busy work is sort of reduced or offloaded, and productivity will increase. And so if you think about why you hire a worker and how that worker gets more valuable over time to a company, it's because they have the experience to operate at what I would call sort of the top of the pyramid of the skill hierarchy. In other words, rather than pulling files from a file cabinet or loading up all the things you need to answer a question, the value of most highly paid, highly skilled workers is in reading that information and making an important decision. So for example, in building requirements from an architecture standpoint, or reading a policy document that a company has and making a decision for an employee, there's a lot of busy work involved in that. And LLMs and automation will remove a lot of that and hopefully make businesses more efficient by paying people to do the things they're most valued for and automating the things that are less efficient and less important for that decision process. And so that includes things like doctors reading the latest research literature and those sorts of things. Doctors don't have a lot of free time, but when you go to a doctor, you hope they've read all the latest technology, right, or the latest innovations. And that's an area where summarization and things like this will be very helpful. So a side effect of this, however, that's very interesting from an investment standpoint is some people argue businesses may become less differentiated. And what I mean by that is if everybody's using the same technology at higher levels of efficiency, the distribution of profitability and profit margins may actually compress. And ultimately, the companies that adopt the latest technology, they'll have a huge edge over those that don't or can't make use of it. But within their peers that have all adopted, there's going to be less to compete on. And Aswath Damodaran posited that after this sort of big Gen AI business revolution, where everybody's more efficient, a lot of businesses and business models will look more similar in terms of efficiency. And in his estimate, they'll be forced to compete more on price than necessarily service, because everybody will have sort of 95 percentile output from their employees if they're augmenting with Gen AI. And I think ultimately that's a huge benefit to us as consumers. Mm-hmm. And I think it will, as much as companies will adopt it, companies are very creative. And so they'll learn how to leverage that, I think, to their benefits and again, differentiate themselves. But I think his point is well made. Ultimately, as time bears out the adoption of this, similar to what we see with the cloud. So companies have become much more efficient using the cloud, but now everybody uses them. So we've come to expect all sorts of instant updates and things to our data interacting with companies.
Wow, that's a really interesting take and view on it.
Well, I think the last thing I'll say in terms of benefits is that it's the application of the technology is interesting, and in a way, I'll close with sort of two or three thoughts here. So if you think about what happened with robotics, right? Most of the cars we drive today have a robot that welded the seams, and it did the same thing over and over again. And we're happy with that because there were no mistakes. And so the quality went up in that. There are still a lot of people that work on assembly lines, but there aren't a lot of people that do the welding for cars. And so I think that large language models and generative AI will do the same, but rather than affecting the so-called blue collar kind of jobs, it's going to affect the white collar jobs more. And in particular, things like tasks where you used to hire an artist or a creative to write something for a product or a trade show or things like this. Large language models are pretty good at generating that content, whether it's a picture, an image. So you're going to see a lot of changes there. There's also a lot of work about customizing images and customizing the context of products that you'll start to see. So people will be able to say, here's a picture of my product. Let's make a background that's appropriate for the ad or the demographic I'm targeting. And so creative, which was traditionally sort of a white collar kind of task, is going to be heavily automated. And the question is, how much? Is it eliminated or is there still a career in that? And for that, I'll talk about another thing. I wrote on this in another article once, which is, if you think about the digital camera, so technology really transformed pictures and cameras to the point where everyone's a photographer now. And for the most part, you don't hire a photographer except for very important things. But for weddings, nobody says, well, for our wedding, we're just going to have grandma or grandpa use their cell phone. You still hire that wedding photographer because that's an important event that you want documented, or there's still sports photographers, but the ability to generate a high quality image is now in the hands of all of us as consumers. And I think the ability to generate great content is also going to be in our hands as consumers of LLMs and generative AI. There will still be a need for great creatives and artists, but I guess what I'll say is, for certain cases, you'll always want that. But for many of the day-to-day things, I think people will turn to this technology. And so depending on the field of work or the level of creativity that's required, we'll see this. We are unlikely to see many tasks that involve manual labor get automated because LLMs are inherently based on knowledge. But for many of the knowledge jobs, your job will be augmented by an LLM. And I don't think it will be eliminated. But if you don't use an LLM, you're going to have a hard time competing with people who are. Well, it's sort of like an extra helper or a coach, if you think of doing your work, and you're going to tend to get better and produce better content over time versus someone who's not making use of that.
Well, we'll definitely see some changes. I'm sure it's, ChatGPT is definitely commonplace now, and I'm sure more to come in the next few years. But Don, I just want to thank you for sharing your insights and time. This is a topic I'm sure you and I could probably sit down and talk for hours. So
I've enjoyed it. Thank you. Yeah. And I'm really excited about the future.
Thank you for listening to this month's episode of the CFA Society San Francisco podcast. We hope you enjoyed the engaging discussion. Join us next month for another new episode.